Good day, sir. I am Haider Sega from the SEE2B. Now we'll now discuss my answers on Lesson 2. So, Problem 3.1. The weight of a bridge crane plus its load is equals to 100 metric tons. It has driven by a motor and travels at 1.7 meter per second along the crane rails. Determine the energy that must be absorbed by the brakes in stopping the crane. So in order to determine the energy, the formula that we're going to use is the kinetic energy, which is equal to 1/2 times mass times the velocity squared. So we're just going to substitute here all the givens. And for the mass, since it is 100 metric tons and 1 metric ton is equal to 1000 kilogram, then 100 times 1000 is equal to 100,000 kilograms. So performing the operations, the kinetic energy therefore, or the energy needed to be absorbed by the brakes, is equal to 58,500 joules or 58.5 kilojoules. Next is problem 3.3. 5 people must be lifted on an elevator at a distance of 100 meters. The work is found to be 341.2 kilojoules, and the gravitational acceleration is 9.75 meters per second. Determine the average mass per person. So, in order to find mass, the formula that we're going to use is the weight is equal to mass times g times the height. Then we're just going to manipulate the equation in order to find mass. Then the equation now for the mass is equal to m is equal to w, or the weight, divided by the gravitational acceleration times the height. Then substituting all the given to the formula and performing all the operations, then mass is equal to 349.95 kilograms. But since we are looking for the average mass per person, we have to divide this mass into 5. So the average mass per person now is equal to 70 kilograms. Next, a student is watching piling being driven into the ground. From the size of the pile driver, the student calculates the mass to be 500 kilograms. The distance that the pile driver is raised is measured to be 3 meters. Determine the potential energy of the pile driver at its greatest height. The piling is considered the datum. Find the driver velocity just prior to impact with the piling. So for the formula of the potential energy at its greatest height is PE equal to mgh. So just substituting all the given to the formula. The mass is equal to 500 kilograms, the gravitational acceleration, which is equal to 9.8 meters per second, and the height, which is equal to 3 meters. So the potential energy at its greatest height is therefore 14,700 joules. And to find the velocity, we have the formula PE is equal to mass times the velocity squared divided by 2. So transforming the equation, we have the formula for the velocity V is equal to the square root of 2 PE divided by the mass. So from the previous equation, we already derived the value of B, which is equal to 14,700 joules. So I just substituted it to the formula, and then the P therefore, or the velocity rather, is equal to 7.67 meters per second. Next, an insulated 2 kilogram box falls from a balloon of 3.5 kilometers above the Earth. What is the change in the internal energy of the box after it has hit the Earth's surface? So The formula for finding the change in internal energy is equal to mgh, or the mass times the gravitational acceleration times the height. So from the problem, the given are the mass, which is 2 kg, multiplied by the gravitational acceleration, which is equal to 9.8 meter per second squared, and multiplied by the height, which is equal to 3.5 kilometer is equal to 3,500 meters. So performing the operation, the change in internal energy therefore is equal to 68,600 joules, or 68.6 joules. Next is problem 3.17. A soap bubble with a 15 cm radius is formed by blowing through a 25 cm diameter wine loop. Assume that all soap films goes into making the bubble. The surface tension of the film is 0.02 Newton per meter. Find the total surface work required to make the bubble. In order to find for the total surface work required to make the bubble, we have the formula W, or the work, is equal to negative of the surface tension times the delta A, or the difference between the two area. So for area 1, the formula is equal to pi over 4 times the diameter squared. So from the problem, the given diameter is 25 centimeters. So we have to convert this into meters. So when we convert this into meter, it is equal to 0.025 meters. So performing the operation, the area 1 now is therefore equal to 0.004909 square meter. And for the area 2, we have the formula 4 times pi times radius squared. So from the problem, the given radius is 15 centimeters. So we have to convert this into meters. So it is equal to 0.15 meter. So performing the operation, the area 2 is equal to 0.28274 square meters. So since we already have the two formula, we're just going to substitute it to the equation. So W is equal to the surface tension in the film, which is equal to 0.02 Newton per meter, multiplied by the difference of the two areas. So the total surface work therefore is equal to negative 0.0056 joules. Next is to calculate the kinetic energy of a 3,000 pound mass automobile moving at 60 miles per hour. So in order to find for the kinetic energy, we have to first convert the 3,000 pound into kilograms. So in order to convert this, 1 kilogram is equal to 2.2 pounds. So this will be cancelled. So the remaining unit now is equal to the kilogram. So perform the operation. The mass now is equal to 1,363.64 kilogram. Now for the velocity of the automobile, we have to first convert the 60 miles per hour into meter per second squared. So in order to convert the 60 miles per hour, I multiply into meter per second squared. I have to convert it. I multiplied it by 1 mile, which is equal to 1,609 meter, and 1 hour is equal to 3,600 seconds squared. So this will be cancelled, and the hour as well. So the remaining unit would be meter per second squared. And performing the operation, the velocity now is equal to 268.7 meter per second squared. Now that we have already the needed data, we just have to proceed into calculating the kinetic energy. So the formula for finding the kinetic energy is equal to mass times velocity squared divided by 2. So substituting all the given to the equation, the kinetic energy therefore is equal to 492,227.192 kilojoules. So in order to convert this into BTU, just multiply 1 BTU is equal to 1.055 kilojoules. So these units will be cancelled and the remaining would be BTU. So performing the operation, the kinetic energy therefore is equal to 466,608 BTU or 467 kBTU. Next is determine the time to accelerate a 1-ton automobile from rest to 60 miles per hour. It has an engine rated of 60 horsepower. So in order to determine the time to accelerate, I have to first convert the 600 miles per hour into meter per second squared, into meter per second rather. So in order to convert it, I multiplied it by 1 meter per second squared divided by 0.447 miles per hour. So this will be cancelled and the remaining unit would be miles per meter per second. So next is to convert the ton into kilograms. So 1 ton is equal to 907.18 kilograms. So our new mass therefore is 907.18 kilogram. Next is to convert the 60 HP into watts or joules per second. And in order to convert this, I just multiplied 1 HP, which is equal to 746 watts. So this will be cancelled, and therefore it is now equal to 447,760 watts or 47,760 joules per second. So now that we already have all the data needed, I just have to substitute this into the formula. So the formula for the kinetic energy is equal to mass times volume squared velocity squared is divided by 2. So substituting all the given, so KE or the kinetic energy therefore is equal to 326,672.9 joules. So for the time, in order to find the time, so the formula for finding the time is T equal to delta KE or the KE divided by the P or the power. So substituting the formula, we have substituting all the given to the formula. So the T therefore or the time is equal to 7.29 seconds.